Hi guys, okay, this is the last page of the Data 1F pack, and it's about time series graphs. Now, time series graphs are just line graphs where you have time along the horizontal axis, so that could be time in weeks, months, years, seconds, whatever, it doesn't really matter. And you can see that these numbers are, if we look at this one, the numbers just represent how many people there are at that point of time. Okay, so first one, we've got the number of visitors at a large zoo each year from 1999 to 2004, and these numbers are in millions, by the way. And it says plot a time series graph for these data. Now you can see that you don't have to start at 0 for this axis up the side, but for these ones I probably will, because it goes down to 1.2, which is not a million miles away anyway. So we are actually going to start at 0, and we need to go up to a maximum number of 2.5. So 0, 0.5, 1, 1.5, 2, 2.5. That will be fine on this graph here. Okay. And it's really important to label your axes as well. So that is the number of visitors. And if we write on there that this is in millions as well, then we won't have to put that on the actual numbers themselves. So, oops, this is 0, 0.5, 1, 1.5, 2, and 2.5. Okay. And we've got year along the bottom, and our first year is 1999. And if we do a year on every one of these bold lines, hopefully there'll be enough. Yeah. Okay. So in 1999, 2.5 million. So that's there. In 2000, 2.2 million. And because of the way we've done the scale, this should be nice and easy to plot. 2001 we had 2 million. 2002 is 1.7. 2003 is 1.4. And 1.2, 2004. Now this is not a scatter graph, so we're not now drawing a line of best fit. We are actually connecting together each of those points with a straight line, so it might wobble a little bit. You can see from the graph just to our right that it goes up and down. You'll have seen a time series graph if you've ever seen a graph of petrol prices or share prices or currency rates, that sort of thing. Well, there we go, easy peasy. Okay, question 2, it says this graph shows the number of people going to the cinema over a period of 12 weeks. Oh, hang on, sorry, I missed a question. So number 1B, comment on the trend shown by this graph. Well, what trend is this showing? It's showing that the number of visitors to this zoo is decreasing. Sorry, I don't know what's happening with my pen today. Okay, sorry, question 2. What does this graph tell you about the number of people going to the cinema? Well, again, the general trend suggests that the number of people going to the cinema is decreasing. B, between which 2 weeks did the biggest change in attendance occur? So we're looking for a steep line. It could be a decrease or an increase. So between week 1 and week 2, it's gone down 100. Yeah, it's gone down 100. Between week 4 and week 5, it's gone from 940 up to 1,500. So that's a slightly bigger increase. I think that is the one. So it's between weeks 4 and 5. And that was an increase of 110, I think. Yeah, hard to see the lines there. Number 3, the school canteen manager notes the quarterly turnover as follows. Which year has the biggest turnover? So we're just going to add together each of these rows because that is a whole year. So this first one, I'm just going to do this in my head, so that'll be 13,000, 15,000, 23,200. 2013, that would be 11,000, 12,600, 20,800, I think. And 2014, 9,000, 10,200, 17,700. I've done that right. So the year with the biggest turnover is 2012. Given reason why the third quarter is the lowest in each year. Okay, well, if this is about a school canteen, can you come up with a reason why July to September would have the lowest income? Well, if you think about the school holidays, they go during that period, don't they? Almost all of August and part of July is holiday, so that's why the school canteen takes less. The final question says, plot a time series graph for these data. It looks really hard to plot one for this because it's kind of like a two-way table, but it is showing time in a kind of linear way actually if you follow it. So we've got the first few months of 2012, then the next few, then the next few, and then the final few, and then we go on to 2013. So we just need to kind of imagine this as one single row. We would have these 4 bits of data first, and then those 4, and then finally those 4. So what we're actually going to do is have time along the bottom, and we're going to label it year, and we're going to have January to March, April to June, July to September, October to December, and that's all going to be for 2012. Oops. So that's one way we could do that, and then we're going to carry on straight away from that, and we're going to have January to March, April to June, July to September, October to December, and that's 2013. And the same again. Okay, so there's our horizontal axis. And on the vertical axis, we're going to have turnover, and turnover just means money received, by the way. Okay, and what's the biggest number we need to go up to there? 7,500. Oh no, there's an 8,200. And there's quite a low amount as well, 1,200. So starting at 0, I think would be fine again. Okay, and we need to go up to 8,200. So 2,000, 4,000, 6,000, 8,000. Probably the best way to do it. Going up in 2,000s. Oops. Okay, which means each one of these little squares represents 400. Okay, so 7,500. Well, we're just going to do this kind of roughly there. That would be 7,000. 7,500 would be about there. They allow a bit of leeway when, if you were asked to do these questions. Very unlikely, to be honest. 5,500, 2,000. Okay, I'm going to do the rest of these and then join them all up, and I'll pause the video here and sort of reveal the answer in a second. There we go, that's what the final graph looks like.